Alright, so going back and looking at that, what we are concentrating on here is we are concentrating on the man's jump. Alright, so let's think about this for a second. I want you to concentrate more on just the actual jump. So that would be 48 seconds to 53 seconds in the video. You have the link at the top of your paper if you want to be able to go in and manipulate that and slow it down and whatever. Alright, but you can do that if you would like. So I want you to look at the start of where he is jumping. How high is he up? He is actually 36 feet in the air. Okay? He is actually 36 feet in the air. So when we are going to graph this, our graph is going to start here at 36 feet. But then I want you to pay attention to his motion. Does he just go straight down? No, if you pay attention, he actually jumps about half a foot before he starts falling. Okay? He actually jumps about half a foot up before he actually starts falling. Alright? So let's look at some numbers. We're actually going to look at some numbers before we start putting this on our graph. I'm going to create a table. Alright, and this is going to be our time in seconds. And this is going to be our elevation in feet. Alright? And we already know he starts at 36 feet, and that's at 0 seconds. He hasn't done anything. Alright? So now we've got to look at what he is doing. How is it that he is falling? Okay? If you are very careful at paying attention to this video, you will see, by slowing it down, how far he jumps. Alright, and yours may not be exactly like mine, but after 1 second, he is actually right around 35.5 feet. Now remember, he jumped up half a foot before coming back down. Alright, so I'm going to give you some data here. Alright, so at 2 seconds, he's about 32 feet. At 3 seconds, about 24 feet. And about 4 seconds, he's about 7 feet. And it does not take him a full 5 seconds to get to the bottom. It only takes about 4.3 seconds for him to end his splash. Okay? So you can see here on this data the time that it took and how quickly he fell. And kind of like the ball we were talking about. Remember, we talked about the end of the ramp. The further it gets down, the quicker it starts rolling. Look at this. He starts falling pretty quickly. He lost a lot of footage there. Alright. So, looking at that data, you're able to see what he has. Now we can take this data and we can start putting it on our graph. We've already graphed the point of start here. We said that at 0 seconds, he was 36 feet in the air. Pay very close attention to how your seconds are done on your graph. They have already labeled it for you, and they've done it in half seconds. Okay, they've done it in half seconds. So be very, very careful. So I've got to go to 1 second, and he was about 35.5 feet. Which would be about right here. All right, at 2 seconds, he was at 32 feet. And it gets kind of tricky here, following those lines. At 3 seconds, he was at about 24 feet. And we need to extend our graph because they actually did not do 4 seconds. So at 4 seconds, he was all the way down here. And then we'll go about 4.3 is where he ended up right here. So our graph, now we can connect those dots. And mine didn't connect perfectly, but that's okay because you get the idea. This is what our graph looks like. Okay? Once again, he didn't come at a constant rate, so we should not have a straight line. He did not fall the same amount of feet every second. He fell faster towards the end than he did to start with. All right, let's flip over and let's look at example number 2. So example number 2 says this. It says, the table below gives the area of a square with sides of whole number lengths. Have students plot the points in the table on a graph and draw the curve that goes through the points. All right, so here's what we're going to do. We need to draw a graph. Now, here's what I want you to pay attention to. It says, on the same graph, reflect the curve across the y-axis. So we actually have to have a graph that has an x and y axis. Okay? Because we're going to reflect. Reflect, think about a mirror. All right, so we're going to do this. This is our x-axis. This is our y-axis. All right. We're going to do our sides here. So 1, 2, 3, 4. I want you to think about this for just a second. When I go to the left side of my x-axis, what kind of numbers do I have? Hopefully you said negative. So I need to make sure I label this accordingly. All right. Now I'm going to look at my area. I've got all the way up to 16. So, and it looks like I've got 0, 1, 4, 9, and 16. So it'd be kind of hard to do counting by twos, but you could. All right. So we'll go 2, 4, 6, 8, 10, 12, 14, 16. Guys, here's super important information. Notice that my spaces are pretty well even. They're not perfect. If you have trouble with getting your spaces pretty even, grab you a piece of graph paper. Graph paper is wonderful, especially when you're creating graphs. All right, so if I have 0 sides, and our x-axis is our sides, our y-axis is our area. So if I have 0 sides, it has an area of 0. That kind of makes sense. If it has 1, it has an area of 1. If it has 2 sides, it has an area of 4. And all I'm doing right now is reading that graph. If it has 3 sides, it has an area of 9. I'm sorry, I'm reading the chart, not the graph. 4 has an area of 16. And look at this. It wants us to reflect across the y-axis. All right. So 0 has 0, 1 has 1, 2 has 4, 3 has 9, and 4 has 16. And I want you to look at this, guys, because this is going to become one of your best friends. Look at that graph. This is an example of a quadratic function. You're going to need to know that. You're going to need to use that probably the rest of your high school math career. That is an example of a quadratic function. All right? You should have, as 8th graders, seen this look like this. If you were to type this into a graphing calculator, A is equal to S squared, it would come up something that looks like this. Okay? We'll be studying these functions throughout the year, and you're going to learn different ways to recognize and represent these quadratic functions and their equations. All right? All right. If I were to go back, I'm going to go back for just a second. Go back to your exploratory challenge. If I actually were to go back to my exploratory challenge, and I were to reflect this across the y-axis, which I didn't do it perfectly, but just to kind of give you an idea of what it would look like, does this extended graph that I've drawn from the exploratory challenge model the elevation of a man jumping into the shallow pool? This part right here, would that model him jumping into that shallow pool? No. The part of the graph before 0 was not good. All right? He went up the platform very slowly compared to how fast he came down. So if I wanted to model how he went up the platform, it would be a lot different. He came down a lot quicker than he went up. Can you imagine an elevation versus time situation where the graph would look like this extended graph? Maybe when you jump into the air. Okay, something like that. Does the reflection of the graph along the y-axis in example 2 make sense? Going back to this one, does this make sense? Can I do this over here? Think about the situation. I'm talking about figures with sides and their area. Can a figure have -1 sides? Can it have -2 sides? Can it have -3 sides? No. So this graph would not make sense if I extended it. This one, if I covered this part up, would make sense. But this part does not make sense with this situation. Just because I can draw a graph does not mean it makes sense. You have to make sure it makes sense with the situation that you are dealing with. All right, guys, that's day 2.